Okay. I was talking about the project with someone in the break, and I referred to Jara. Can we all just congratulate Jara for getting 100 for 1927? It's amazing. How did you do it?
How?
Yeah. Right. That's right. And tell everyone what you did that made me so happy.
100?
No, 100 wouldn't do it. Remember you tried 100, it wasn't enough.
Did you make it too? I don't know, my accountant took care of it.
Okay, your accountant took care of it. This laptop. Yeah, no. He did well of his own. He did fantastically well. 100 is a very rare thing. We don't hand it out automatically, though often it is one because the people doing that course are so keen, as you guys were last year. But congratulations to Jara for doing that. That's quite amazing. And look, congratulations to everyone. I don't know if I've seen you all since 1927 and said, well done for doing so well in 1927. If you remember at the start of 1927 last year, I was a bit scared because we seemed to be a bit behind where I wanted us to be. And by the end, I was so proud of you guys. It was just amazing. So, well done. Okay, now this is, Rupert just wanted me to show you this. Shh. No. Let's... Ta-da! Here are the projects groups for Rupert's Tute. They're on the wiki. So you can see who you are. All right, now I want to start writing some code now. Do. Oh, no, I want to start showing you some code. Oh, we're going slower than I want. I'm going slower than I want. Schedule. Is Nick Kleins here? Nick, you left your notes behind in the Tute? Your book of 2911 notes? And I've got them in my office if you want to walk back with me at the end, if that's important. Yanjing, Yanjing your tutor? She got them to me and then I forgot to bring them here. So, yeah. Okay, let's have a look at this Java program. Oh, how do I make it bigger? Bigger. That's what I was trying. Oh, no, it wasn't. Trying Apple Plus. Here we go. Let's just look at this. Here's a Java program. We're representing a game. Suppose it's Fury of Dracula. Remember last time you had an ADT called the game and you had to represent the whole game state in it? So I wanted to show you what that looks like in Java, just lightning fast so we can talk about one or two features. Now, suppose to represent a game of Fury of Dracula, of course, in the assignment when you did it last term, you had to record the map of Europe, where you were, your points, whose turn it was, how much blood everyone had, all that sort of disgusting stuff. But let's suppose all you needed to know for the game was a name and a number. That's all you needed to store in that type. Oh, go away. Why isn't... there we go. So here's our simple class, public class game. It's a class called game. It's in a file called game.java. It's got two attributes. These are fields stored in the class. These are not local variables. Remember C, the way local variables were declared inside functions in C, they worked perfectly, didn't they? We saw they were created on the stack, and when they were finished, they were disposed on the stack. So Java doesn't monkey with that at all. Java copies that exactly. You declare local variables inside your functions, then when the function's called, they're created on the stack. When the function exits, they're destroyed. It's exactly the same as C. But in addition, we have these abstract, sort of more malloc-y things, the thing that belongs to the whole class, a piece of persistent data that lives outside of a function called. And this class here has two, an int called ID and a string called name. Which of these attributes is abstract? The ID. Name, anyone can change. So anyone can change the name of this game. If I pass you a name, you can change the name of the game. That sounds almost like an ABBA song or something, doesn't it? Could have worked something into that. But the int, no, you can't see it, you can't touch it. It's got a constructor here to create a game. So whenever we want a newer game, to make a new game, the equivalent of a malloc, Java behind the scenes set the memory aside and then it runs a constructor on it. And the constructor function, what does it do? It takes in an integer and it says ID equals identity. Okay, slightly confusing. Can you tell me where's the library? Yes, it's just up there. Can you tell me where's the library at Sydney University? No. No, but suppose you can. Just lie. No one knows.
It's by the garden.
It's by the garden. It's by the park. It's a beautiful Fisher Stack. It's a very big, tall building. Which one? That's right. There's lots of them. There's lots of them. Sydney Uni has many libraries. It has a law library and it has a vet library and has a fishing library. Yeah. Okay, but let's not talk about Sydney Uni here, though they're fantastic and we love them very much. The thing I wanted to point out is when I asked, who did I ask first? When I asked you where the library was, I didn't say, where's UNSW's library? How come you knew what library I was talking about? How did you know I meant this uni's library? You just knew. From the context, we're at the uni. If I don't say what library I'm talking about, you assume it's the uni's library. If we were just walking down the street in Strathfield and I said, where's the library? You'd probably think I mean the Strathfield library. If I was just in Canberra or in Australia and talking about the library, you'd probably think if there was no more closely local library, I might be talking about the National Library. So if I don't tell you precisely what I mean, if it's ambiguous, we normally resolve it by picking the most specific instance we can think of that's close to where we are. So it's the same in Java. If I'm talking about the field here called serial number, I told you before I had to say it was S1.serial number. Give us that serial number. But if I'm inside an object and I casually say, I'll get the serial number and add 1 to it, and I don't say object.serial number, I just say get the serial number and add 1 to it. So you have no idea which object I'm talking about. Hundreds of objects could have serial numbers. Which object does Java assume? I'm inside S1, the S1 object, and I talk about serial number. So we're going to assume it's the serial number of S1. I'm inside the UNSW object, I just say library, we're going to assume it's the library of UNSW. I could say UNSW.library, I often do that. Excuse me, sir, could you tell me where Sydney University.library is? No. Here's a common answer. Okay, so it's the same here. We're saying ID equals identity. What that really means is this.id, the attribute, is equal to identity. Identity here is a parameter passed in, so it's pushed on the stack. ID is the attribute of the whole class. So once I've set it, the class keeps that value forever. It just lives inside the class. But when the function exits, any variables that belong to the function, the parameters passed in and anything declared locally in here disappears. But yeah, this lasts as long as the object lasts. Does that make sense? So this is saying initializing the object's attribute to be the number passed in when I construct it. And Java's pretty cool. It lets you have multiple functions with the same name. As long as I have different signatures, Java can work out which one you mean. So here we've got a construction function that takes in a single parameter, which is an integer. Here we've got a constructor which takes in no parameters. So if I say G equals new game, empty brackets, it's going to call this constructor to construct the game. And if I say G equals new game 42, it's going to call this constructor to make the game. Yeah, it'll work out which of the two functions to call based on the actual number of parameters and their types. So this one here says essentially this.id equals 18. So the default is if you don't give me an identity code when you create one of these things, it gets the default code of 18. Now let's give it a method. So let's give it a, with a constructor is one method. Now let's look at another method. This is public, so anyone in the world can use it. Get ID. Get ID returns ID. It's really returning this.id. So no one in the world can see the ID field because it's private. But if they wanted to find it out, they could simply go, if G was a game, they could go g.getID. And that would return the ID of that object. So this is how we get our protection, our encapsulation. We hide the field, and then we have functions that can access it and return the value. Sometimes we have just, this is called a getter function. It gets an attribute and returns it to the outside world. And sometimes we have setter functions that set the attribute, that set it to a value. They're just, it's not a special sort of function, it's just a name we give them. Yeah, it's just a function. And just for fun, woohoo, I stuck an extra function in the class. I gave it a main function. Oh, why not? It's nuts, but I did it. It's a sort of zany thing we do here. Now, notice it's a sort of main that the system's happy to see as a main function. It's public, it's static, which means it only lives at compile time. It doesn't belong to an object, it belongs to the whole class. It doesn't belong to objects, it belongs to a class in static land. And the main function, all it does is prints out hello from the game class. So if I wanted to, there's no reason I couldn't go, if I had a game called G, an object G, which is of type game, I could go g.main. And I have to pass a string in, empty string, and it would print out hello from the main function. And if I started Java off, I'm going to compile it first of all. And if I start Java off and tell it game, I'm pointing on the screen with the pointer. It's insane. So here I'm running game and I'm saying starting Java off with game because a Java program, all it is a whole lot of objects floating around in space calling each other's methods. That's what a program is. This object calls the methods of these 5 objects. They in turn call these methods. And it's like a billiard ball thing exploding around the table. Each one sets off others and sets off others. And all the program is a collection of objects all calling each other's methods. And you need to have something to start it off, and we call that the main function. That's the one that goes bing, sets the first ball rolling. So if I run the Java VM, that turns on the Java virtual machine, and I say do the game class, then take the game class, game.class. It's going to run that, and it's going to look for the main function to set it going. And I happen to give game a main function, so it'll run that main function. And it'll say, hello from the game class. Still not very useful. So let's create another class called game user, which is going to use this object. We're going to use game objects. All right, so here's another class. It's called gameuser.class. Oh, it's called game user, so what files are going to be put in? Gameuser.java. Gameuser.java, that's right. It's got and it itself also has a main function. So if I compiled it and ran this one, I'd get the message saying hello from game user class. Now I'm going to declare some variables. Game is of type game 1 is of type game 2 is of type game, easy is of type game, hard is of type game. Are these attributes or local variables? They're local variables because they belong to a function. They belong to the main function. They're just declared in a function. So they're just local variables. They're these little dots we were talking about before. They're local variables. So I've now got 4 local variables, and they're of game type. Does that mean how many game objects do I now have? None. None. Because an important thing to know about objects, which I haven't told you yet, is they're just like the way we did ADTs in C. The Java represents objects as a pointer to a struct of its own. An object, as far as Java is concerned, is a pointer to an object. Now Java, one thing, what do we hate about C? We had to say one thing, and it rhymed with ointers. What would it be? Where we make all our mistakes, where everything goes wrong, where our brain explodes. So Gosling sat down and thought, well, one thing in Java, we're not having any pointers. Now, of course, Java has pointers behind the scenes, but every object, when I have an object, I never actually get the object. I always just get a pointer to the object. And Java, because it doesn't even want to have the word pointer appearing in any manual that has the word Java on the front, they call pointers something else. They call them references, but it just means pointers. So in a Java program, if I say game G, what that's saying is G is of type game. Game's going to be an object from the game class. So G is going to be a reference to a game. So at the instant that the compiler sees this line, it sets up a tiny little bit of memory here, just big enough to hold a pointer, and that could be used to point to an object. But no objects have been created. How can I create an object? The only way I can create an object is by the new function. So let's keep going down here, and you'll see. We have now 4 pointers, references to games, thank you, but we don't have any games. And in Java, one other thing about C is C it doesn't really initialize things. It's up to you to initialize things. And Gosling thought, that's no good. I want Java to initialize things. So when you declare things in Java, they get given sensible initial values. Now actually, I must admit, I hate this. I think defaults are no good, and you should actually explicitly give things a value, not relying on the system. But anyway, the default is null, the null pointer. So game1 at the moment will contain null, yep, which means it's pointing nowhere. It's not referring to anything. So game1 is null, game2 is null, game3 easy is null, and hard is null. They're not pointing anywhere, they're null. Okay, now we're going to initialize them. Game1 equals new game. So now game1 is pointing to a new game creates a new game object, and game1 points to it. So at this point in the code, how many games do we have? Game objects. How many pointers to game objects do we have? 4. Okay. When it creates this new game and assigns a pointer to it to game1, what function does it use to fill in the parameters? Well, let's have a look. It used the default function. So the ID of this game will be 18 because when we called the creator constructor function, we gave it no arguments. So it used that function. And then when we say game2 is new game 10, it uses a different function. Going back up to the top. Now it uses this constructor function. And identity, this.id is set to, was it 10 or 18? 10. I've got ID inflation. And then easy is set to a new game. And easy.name is easy game. So at this point, how many objects have we got? And what does hard point to at the moment? Null. If I said game 2 equals game 1, what's going to happen? What would happen in C? Suppose this is game 2. This is game 1. And suppose initially they pointed like that. Let's say it the other way around. Game 1 at the top, game 2 at the bottom. If I said game 2 equals game 1, what's going to happen? Does this get copied into here? No. No, no, no. What happens? Game 2 now points to game 1. Does that make sense? So the two objects are now pointing to the same object, which could be confusing, couldn't it? Because you could have an object, assign it to another object, and now you've got two different names for that object, and some smart aleck could update it using one of the names, and you've got the object and suddenly it changes on you, because there's two ways of referring to it. This object has two guys referring to it. How many guys are referring to this object as I've drawn it? None. Now what happens if no one refers to an object? It's a leak, it's a memory leak, it's a disaster. And I told you Java didn't do that, and I was clearly wrong. Because it's possible to have an object now. We could create an object, then assign its pointer to something else, and now no one points to it. There's no way of ever getting hold of it, no way of ever doing anything with it. But what does Java do? Garbage collects it. As soon as there's no one pointing to it, it goes, yum, 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 cookie, cookie, cookie. Because there's no way anyone can ever get to it anymore, because we don't have pointer arithmetic, and we don't have any of that mucking around, so it's inaccessible to anyone as soon as there's no reference to it, so it's safe to garbage collect it. Okay. Let's have a look here. We've got some integers. Look, I think everything else is pretty simple. Okay. Now I want to write a program. Here's what we're going to do. How long have we got? We've got some time. We won't get it finished, but we'll get started. I want to write a program to represent a car. We're going to be sort of modeling a car. Because, you know, objects are quite good at modeling things. So let's think about what a car is. A car has wheels. I should write this down. This is good stuff. You guys are very good. This is what object meetings look like. We're all standing around a whiteboard going, a car has, an account has. Do I need to? We don't need to look at this anymore, do we? Car. It has wheels. Oh.
Fluffy dice.
It has fluffy dice. But let's do the important things. We could put fluffy dice on it, But we've only got 20 minutes left. We've only got 4 days before we have to release version 1.1. So let's put the main things in. It's got an engine. It's got a steering wheel. Has brakes. Has an accelerator. Look, I told you before, my brother-in-law had a car that kept exploding. But every time they pulled up to show us their fantastic car, he didn't show us the engine. He didn't show us the wheels or the brakes or the accelerator. Much more important to that for their whole family, including their young children. What was the best thing about the car was the sunroof. For them, that was the most important feature. In fact, when they were trapped in the land of the leeches, they didn't mind because they could keep turning the sunroof on, shut, and then push it, it would open. So a car has a sunroof. I think we've got all the main features now. Doors, seatbelts, passengers, petrol tank. It's got lots of stuff. So what we're doing is we're thinking the whole system, we're trying to break it into its components. And this is how we write an object-oriented program. We try and identify what are the objects, what are the classes. So if we're going to be writing a program to represent a car, then the first whack at it is we try and describe what a car is, and then we look at all the nouns in our description. And then we think, well, they're good candidates for classes. So maybe I should have a wheel class, a wheels class. Let's not break it into individual wheels at the moment. Later on, we'll probably should. We should have an engine class, a steering wheel class, a brakes class, an accelerator class, a sunroof class. And they should probably all be related to the car class. And then we start thinking about the relationships between them and their responsibilities. What are the relationships between them? The accelerator controls the engine. It sort of collaborates with the engine. It affects the engine, drives the engine. The engine controls the wheels. The brakes control the wheels. The steering wheel controls the wheels. Oh! Refactoring. Let's simplify the design, because I didn't want to draw more arrows. It was going to get a mess. Have we got everything? The sunroof is just awesome. All right, that's looking pretty good. The car itself, what does it control? Probably mainly controls the brakes and the accelerator. Would that be right? You don't directly interact with the engine, do you? Oh, you do, to turn it on and off. Yeah. So on and off. Connects to the engine. All right, so we're probably going to need a car class, a wheel class, an engine class, a brakes class, an accelerator class, and a sunroof class. Oh, the car controls the sunroof. Thank you. And they collaborate in various ways. The brake needs to know about the wheels because it's going to tell the wheels to do stuff. The engine needs to know about the wheels because it's going to do stuff. The car doesn't necessarily need to know about the engine. Oh, but I guess it's part of the car, so it should probably have it. The accelerator needs to know about the engine. Okay, all right, let's go. So let's start writing code. This is going to be the world's fastest code. We all know that's a lie. It's going to be the world's slowest code and we're not going to finish, but let's pretend it's going to be the world's fastest code. Okay, oh, well, it's not a good start because you can't see what I'm doing. All right, we've got a blinking light. That's a good sign. I'm going to run a program called Eclipse because that's going to help us write the code fast. You should download Eclipse. It's awesomely good and free. You don't have to. Oh, well, no, shh. I'm not compelling you to. You would be mad not to. It's going to be very, very hard to write code. Now, John, he's not here. When I taught John, oh, I've forgotten his name. John Garland, years and years ago, back in 2007, he hated Eclipse so much. Am I right in remembering this story? He refused to use Eclipse. Oh, he hated some things anyway. So he did it all himself. He hated JUnit, so he wrote his own John unit, which was actually quite good. And I'm pretty sure he didn't use Eclipse. I'm pretty sure he just used Notepad and had 5 million copies of Notepad open for the 5 million class files. You can do it, but you know, I really wouldn't want to. Okay. So I've started Eclipse. Here's what it looks like. Now I'm going to have to create a new project. I'm going to call it, oh, look at all the different sorts of wizards it's got. It's very exciting. Java. I want a Java wizard, please. I just want to make a Java project. All these options. Wow, all the things I could be making. And we'll call the project, what are we going to call it? Car. Yep, good name. Notice I'm using Java SE -1.6. You guys know what that means now. I'm using Java Standard Edition version 6. It's the one to use. It's the one we got in the labs as well. Oh, now, did I tell you if you've got a Mac and it's not the very latest version of the operating system, if it's not, you're not running Snow Leopard, you can only get Java 5, I think. You can't get Java 6 because the write once, run anywhere thing only works if someone actually implements a JVM for you. And Apple are incredibly slow at writing JVMs. So they've finally written a 1.6 JVM, woohoo, but only if you've got Snow Leopard. You could try 1.5. The language hasn't changed that much between 1.5 and 1.6, but I'd certainly check all my code at uni before I submitted it if I was writing it in 1.5. Okay, so I'm making a new car. All I did was write the name in there. I didn't pick any other options. Whoa, it's created the car thing. All right, so now I'm inside the car project. I'm going to go File, New. I'm going to make a new class. And what's the class called? It's called car. Car. Remember, classes start with a capital letter. Anything else? Do I want to put a main function in? Let's do it. Woohoo! Makes it for me. Thank you very much. Quick. There it is. Oh, it's a bit small. Let's look at it. It's made it. It's made the main function, and I'm just going to print what? System.out.print, and it starts suggesting things as I type. It's very exciting. It almost writes the code for you as you go. Hello from car. That's it. That's our whole program so far for car. Now, let's compile it and run it. Yep, save everything. Always save everything. Yep. Woohoo! And it ran, and here's the console down the bottom. Hello from car. So it's working. So what I'm going to do is I'm going to be changing the code, and every time I change something, I'm just going to click this green button. It's going to rerun it for me. That's really exciting. Now, we probably should be starting to write some tests. The problem we're going to have with the car is we're going to implement, the idea I have for us implementing a car is it's going to be a very stupid car that doesn't do anything. We're just going to have the relationship between the components. And I'll have little print statements to print out things when things are happening so you can see the relationship. But as a piece of code, it doesn't do anything. If it doesn't do anything, it's very hard to check that it's doing anything. So it's hard to know how to write a unit test for it, but let's try anyway. So let's write a unit test class now. So I better go File, New, Class, Test Car. Oh, a test car driver. That's cool. Always wanted to be. We better stick a main function in because this is actually a real main function. This is what we'll run to run the unit test. And that will be do some tests. All right, what's the first test we're going to do? Let's check that we can open the sunroof.
Can we test that we can get a new car?
Test that we can get a new car. We can. It's so easy in Java. You just go, new car. That's brilliant. We can really rub it into my brother. I better ring him. You want a new car? Okay. All right. Very good, George. Well done. Okay, so let's say, we're going to say, we better print out hello, we're here. System.out.println. At any point in Eclipse, it's really nice. You can go control space, and it'll make a good guess at what you want and fill it in for you. So we're going to print out testing car. And what do we always say at the end of our unit tests? Yep. So we better put that in. All tests passed. You are awesome. Exclamation mark. Let's check that it works. Woo! All right, we're in. So now let's start doing some stuff. Let's say I better create a new car. So I'm going to say car. What are we going to call our car? Herbie? Have you ever seen that? That dates me, actually. What's a modern car? What's that? Prius. That's a type of car. I want a specific car, name of a car, like Optimus Prime. What's Optimus Prime? It's a truck. No, but is it a type of truck or a particular truck? Oh, okay. All right. Optus Prime. I'm going to have to type this over and over again. I really just want to say OP, but okay. It's funny that 2 seconds, if I keep doing this, you guys are going to keep laughing. Oh, it's a bit smaller every time, but there you go. Okay, so car Optus Prime equals new. To make a new one, I've got to go new car. And then what am I going to do next? I'm going to say Optus. Now, I don't want to type Optus. I'm just going to go control space, and hopefully it's just going to fill it in for me. Thank you. Optus prime equals, now what am I going to do? I'm going to dot open sunroof. And then I'm going to go assert dot sun roof open. Is that looking good? Assert that it's open, and then I better shut it, and then assert that it's shut. Oh, and we're going to assume that when we create a sunroof, it's always, when you buy the car, the sunroof's shut. And that, of course, is the case. Otherwise, it would get full of water. And, oh, no, I just wanted this line here. Now, remember, those of you that I taught a long time ago in 1911, I used to say the way to write code is you write it just pretending all these functions are there. You don't worry about them. This is like what we call top-down design at that point. You just write it assuming the sub-things are there and you keep going and you plow on regardless of the fact they don't really exist. And later on you can go back and fill all the details in. What am I looking for here? Assert it's not open. Well, now if I tried to run the unit test now, it's got an error in the project. That's not good. Go ahead anyway. Oh, errors. What are the errors? Well, give me these little things on the side. The method sunroof is undefined in type car. So what do I need to do? Well, let's see how I do that. What I do is I click on the cross, and it says, what would you like to do, master? And I say, yes, please. Create an, and it's done. And then let's go back to test car, and it'll say, the method sunroof open is undefined. Oh, well, please put it in for me. And what else? Close sunroof. Oh, well, we need to have that method in there. Boom, boom, it's put them all in. Now let's run the test. Now, it's not going to work. I don't mind that. I expect my test to fail at first. In fact, if my tests pass and I haven't done anything, it means my tests aren't very good. But I'm going to run it now because this is how we do it. We write the tests, we run them, they fail, then I go and put in the details to make them pass. And if they pass, I don't have to put any more details in. This is part of this thing we were talking about before. I can't remember who it was with. I'm not going to do anything fancy anticipating future problems. I'm only going to put in as much as I need now to pass these tests right now. So I'm not even thinking about the steering wheel at the moment. Let's compile it, run it. Woohoo! Awesome. See? All tests passed. We're awesome. So that's a bit suspicious though, isn't it? Hang on. Open. I should have closed it there. Oh, that's no good. It's going to want to create a function. Create it, please. Okay. Let's run it now. Oh, we passed again. We're so awesome. Now that's a bit weird. It changed it back. Oh, I need to pay a little bit more attention to my underlings. Did it say one way of fixing this is to change it back? Yes, it did. No, I want you to make a new method. Thank you. Aha. Let's run it. Woohoo! Hello from car. Oh no, I'm running the car. Phew. I need to run test car. I keep passing the test. Now, after a while, you get a bit suspicious. I say open it. I check it's open. I say close it. I check it's closed. I haven't written anything to open it, to close it, to check it's open, or to check it's closed. How can that just work?
Because you're awesome.
Because someone was saying it. Who was saying it? I heard someone in a row or two back. Thank you. I haven't turned on assertions. Classic blunder in Java. If you don't turn assertions on, it won't actually check any of your tests. It's ignoring all the asserts. So how do I turn it on? Eclipse. Preferences. There's probably a faster way, but I'm not sure how to do it. I just want to find their preferences. General. No, that's no good. Java. Compiler. No, that's not the compiler. It's a runtime. Oh, it's run. Remember, I need to tell it at runtime what to do. Run, console. Oh, gee, I'm lost now. Does anyone know? Java. Maybe it is Java. Maybe I was wrong. Build path, compiler. It's not a compiler option, it's a run option. There's a filter at the top. Oh, yeah, thank you. Maybe that'll help me. So I'll go, what do I want to find? I want to find EA, maybe. Command. Options. Configure project specific settings. Now this is annoying. Well, it's good that at least we're stuck in a passing state. It's not but yeah. No, there's a little place where I type a command line in. I'm just trying to pass arguments to the JVM. Oh, it's not in preferences. That's right. It's in something else. It's in console. Oh, no. It's run. Yes, thank you. Configuration is what it's called. Thank you. Whew. So run configurations. Let's go. It's showing me the configuration it uses when I run it. Thank you very much. When I run test car, I want to pass in the argument of to the VM negative EA. Whew. Apply. Thank you. Run. Now, I threw an assertion here. We collapsed. Our error didn't pass. Our code didn't pass. That's what we wanted. That's good. Everything's good. We're happy now. Let's just quickly look at car. I think we've only got 1 minute left, so let's just talk about what we do. You can see the functions that put in do nothing. What am I going to need to do to store the state about whether the sunroof is open or closed? Not a variable, because variables get lost when the function returns. I'm going to need an attribute of the class. Will it be public or private? Private. And then our functions will access it to set it to true when we open the roof, to set it to false when we close the roof, and to query it when we query if the roof's open or closed. Can you all try and do that for Thursday? And I'll post this up so you can do that with it. See you on Thursday.